I'm recording the WebEx as well. Good evening, everyone, again. I really appreciate everyone for taking time and you're joining this WebEx. So this WebEx, specifically, I just wanted to start introducing the SQL concept. And based upon my observation, I think there is some misconception and misunderstanding of the concepts. Especially I'm talking with respect to the class I teach. My name is Prasanna Menta, and I teach one section of Data 620. There are three sections, and three professors are teaching. One is Carrie Bain, and Majid, and myself. So we share the WebExes, and we host this WebEx at appropriate times for the benefit of the students. Today, the total WebEx will be focused on SQL, then ER diagrams, and how you execute scripts in order to create the structures in the database. That is what we want to walk you through. And I have Christian, I have Deepa, I have Majid as well as on the call. And just for the benefit of everyone, please mute your microphones. Number two, I will not be able to see any of your text or chats. So I will be depending upon Christian and Deepa, who are the faculty assistants for respective classes, and they have to raise any questions or anything that is being asked. So I will go over the concepts and give some breaks so you can ask me any questions you're not clear of. And also, in my first webcast, I gave an indication this is a new tool, new virtual desktop we are deploying. Don't get upset with the connections and things. We are trying to fix if there are any challenges as we progress to the class. Please reach out to the faculty assistant, always copy your faculty. We know that you have difficulties. We will try to help you, accommodate you as needed. Number two, the most important one, start the assignments earlier in the week. Mainly, we open up the assignments the first thing on Monday. So please look at the assignment and plan yours. Do not ask a question on the date of the assignment, which is Sunday, and it's very difficult and very challenging for everyone. So plan if there are issues, we will work with you, we'll help you. If there's a need, we will make sure you get appropriate time, resources, attention. So do this, that will be helpful for both of us, and will make this course a most enjoyable and memorable one. So let's start, and I've asked Deepa to take over in the middle of the webcast. So what I'm planning to do is I just wanted to go over a little bit of SQL background. I've seen some of them do have, some do not, and there's some kind of clarity that has to be given for your understanding. SQL is nothing but structured query language. It's called as SQL. So we write commands in a structured query language and execute in the database to get the information what we want. That is where SQL is used. So I'm not going to go over the entire SQL course, which is DBST 651. But I'm going to cover some of the key essential concepts which you need to understand to complete the SQL assignments until week 6. These are basic fundamentals I'll give you in an extract. Always you can reach your faculty members or TAs for any assistance you need with any of your questions. So what are columns? In a database, we store data in tables. Some applications called tables, some applications called entity, and some call as records. I have been in the IT for over 20 plus years. Various applications use various naming conventions. So for this course, we call them as entity or tables. So entity or tables are mainly the structures to hold your data. Let us look at an Excel spreadsheet. The top line of the Excel spreadsheet, we put some column information. So that column information corresponds to the column in the database itself. They are the identifier for the data, what type of data, what data is stored in a table. So those are called as columns. The rows of data where you enter and it is stored, they are called as rows in the table. So a table is comprised of columns and rows. Now, when you look into the data types, at least for this course, let's look at numeric, character, and date formats. Okay, so numeric means it's nothing but if you want to describe the column as a number, that is called as a numeric format. Okay, when you use a numeric format, when you do an insert, you do not need the single quotes. So we'll show you what to do the inserts. We will take a simple case study and we will walk you through the process from end to end, so you will understand what it is, how we do, what we do, and you will understand in a nutshell. So if you practice using the PDF file what you are given, where it has the manual along with your exercises, it will be very simple and very easy to understand. So character means if you want to use an alpha type of values, then those are called as characters. So there are two types of data types called char and varchar. The difference between char and varchar means in character you have to declare the size, meaning let me say I'm declaring a column called I'm declaring a column called a name. Let's say table is employee and the columns. Okay, what are the types of columns I want? Now I say emp ID. This one I'm calling a number and size is 10, and name I want a character column and size 50. When you say char or character 50, the database holds 50 size of the column irrespective of the data you're inserting. So the size will be reserved always. If you use varchar, you don't need to specify the size. It extends the size based upon your data what you insert. So that is the difference between character and a variable character. So let's not go into the in-depth of why, what we use, how we use. For this course, you need to understand what is a table, what is an entity, what are columns, what are rows in a table, and what are the data types. Then the next important concepts you need to understand is two basic fundamental database entity concepts. One is called as an entity integrity. Entity means it's a table. So for instance, you have a table called employee, what we have described here. So there's an employee ID field with a size of 10, and it's a numeric type, and a name is a character of 50. Now, when you create the entity or the table in the database, you have to maintain the integrity of the table, meaning let's look at some of the data what we insert into the employee table. Like say 001, I'm inserting Joanna. Okay. Now 002, I'm inserting Joe. Okay. Now 003, I'm inserting Jamaris. So now, if you look into these three values, what I have inserted, the first two are unique. Whereas the third value, when I inserted it, when you select from the table called employee, give me the rows of the data where employee ID is equal to 001, you will get two rows of data. but the uniqueness in the table is lost, or the integrity of the table is lost. That is called as entity integrity. Then, how would you enforce entity integrity on a table? We'll talk about that, okay? Now, when you're looking at this table, and when this table is connected to a second table, now, for instance, let's take a course table, okay? Course table will contain course ID, course name, and let's say student ID, okay? Let's take this as student ID for the namesake. So here we want to store the values of the students who are taking a specific course. Now, this course and student table, let's change this table name to student, okay? Now, the student and the course table are connected by means of a relationship. We will show you, understand the concepts, and we will illustrate everything in the database, how to do, how to enforce, and how to create. Everything will show from end to end. Just understand what I'm illustrating. Now, the student and the course table are connected by a relationship. When they are connected by a relationship, we want to make sure we enforce the students are valid students who are registered. So in our example, let's change this to 3. Okay? There are 3 students. So let's insert a value called, okay, 0, okay, let's say 620 is the course, data visualization, and it has been taken by Joanna. Okay, let's copy this row. Can I insert the second row? Look at the rows of information in student table, and this is the rows of table in the course table. Is the second row valid?
No.
Why?
I'll let somebody else answer.
Okay, because the second row of the student ID 004 is not in the student table. So here, when you do this insert, it will say referential integrity violated. So most important things you need to understand in database is entity integrity and referential integrity. If you want to keep the integrity of a table, you enforce entity integrity, and the entity integrity is enforced by primary keys. Okay. Now, referential integrity is mainly for enforcing data accuracy and make sure there are validations enforced. And those are mainly done with foreign key concepts along with primary key combinations. That is how referential integrity is enforced. So in a nutshell, we have entities or tables. The tables are entities contain rows and columns and rows, and they have different types of data types, numeric, character, or variable character, or date types. Then from there, we are going into understanding entity integrity and referential integrity. Entity integrity is enforced by primary key. Referential integrity is enforced by a combination of foreign key and a primary key along with this. Now, there are other type of keys which play a bigger role. But for this course, we will not go into that concept because it's a 3-hour lecture, what I am just showing in the top portion. Now, after we finish the concepts, we need to create the structures, or we need to make use of our SQL knowledge. So there are 3 types of SQLs. One is called as DDL. DDL is nothing but data definition language. Okay. Then we have DML, which is data manipulation language. Then this is called as data control language. Okay. Now I'm just simplifying it. Some books have a fourth type. Let's keep it simple. Now, what is DDL? So in our example, we have created two tables called student, and we also created a table called course. First, we have to create the structure. When you're creating the structure, we use data definition language. For any create or any drops or any delete or things like that, for structures, we use data definition language. So in our example, I want to create a table called employee. When I want to create an employee table, I use data definition language construct in an SQL and create the table. Now, data manipulation language. Data manipulation language is used for insert, okay. Data manipulation language you will do for when you're inserting rows of information into your table or changing the values or deleting the data in the table. You use something called as data manipulation language. There's syntax and commands to do data manipulation language. The last one is the data control language. This is mainly for administration purpose. If you are a database administrator or you have high privileges in your database, you will be doing data control language where you want to assign privileges, revoke privileges, you want to do some administration tasks. Those are all comes under data control language. So these are basically, in a nutshell, a basic understanding of SQL. So this is normally covered in 6 to 9 hours in a pure data class. We are not doing a data class. Many of you are coming from varied background. I'm just trying to simplify, give in a nutshell various concepts. So when you read the PDF document which has it, and you can relate what I have given as examples, you have to understand, you have to make sure you follow these concepts. Now, one important thing, many of you are making mistakes, I will illustrate. When you are making a table, normally it is a practice to have a numeric column as the primary key. For instance, in our class, we have the first assignment, many of you are in the opera table and the shows table, many are done in a different way. So for instance, when you're trying to do any table for the data, try to have the primary key to a numeric this thing. For instance, I'm just giving like for example, show and date. Okay. This is I am like, let's say so this is one thing. Now, when you look into this data, they have given this show as the primary key. Let's say if you want to have one other show of Jack and Bean, what would you do? You cannot insert another row here. Okay? It will say primary key as violated because this name is the same. So it's always preferable to say show ID. Okay? I'm just giving an example. There are multiple ways of doing. Okay? You can do like this. Now, you can connect this ID and put it into the attendance table or something. Okay, this person attended this show ID then you can connect the table in a relatively way. That way you'll be able to understand. First of all, this structure, you have to understand what are the functions that happens on a table. Then you have to do the normalization. Just not drawing the diagram and connecting, it will not help. You need to understand what type of operations are performed on a specific table, and then think about it, and then you have to do the normalization. Straight away taking the whatever we are given and just draw 3 tables and then connect will not work. You have to think. Then after you do it, you have to verify whether you have done it correctly or not. That is also has to be there. So the last concept before I want to give it to Deepa, there are something called as normalization. That is what we did for week 1. When you are normalizing tables, you have to make sure there is no Okay, so these are the 3 things you have to verify. So after you do a normalization, I'm just giving a simple, easy shortcut to understand normalization. Again, a normalization is a 6-hour lecture we do in DBST 651 course. Normalization, we go in depth how we do normalization right from first normal form until 5th normal form. Then there are formulas, and there is a way how you do normalization. Then there are diagrams you have to do, and then you have to do the normalization. Here we are asking you straight away in an easy way for you to understand. After you do the normalized tables, you have to make sure you can insert a row of information or delete a row or update a row. Meaning, in our example, right? Let's say I have 2 rows of information here, but I want to only delete a specific row. Then you should be able to identify that specific row and delete. That specific row, identify and update. That specific row, you have to make changes. So when you can identify a specific row and without impacting the other rows, that means your table is in a normalized fashion. If you fail in any of this test or there are any anomalies, that means your table is not normalized. So this is a simple test you can do after you have created a normalized structure of your database tables. So this we do, but normally in the industry we stop at 3rd normal form. There is 1st normal form, then we go from 1st normal to 2nd normal, 2nd to 3rd. Some of the industries have highly normalized data. It's for very different purpose. They go to the 4th or the 5th or Boyce code normal form. These are all different normalization metrics. We are not concerned here. We are concerned with simple understanding of a normalized table. How do you test normalization? You can insert 1 row of data. If you can insert specifically without additional data that is needed, then your insert is fine. If you can delete a specific row without impacting the other rows, you're fine. Then when you're doing updates for a specific data, you should be able to do that. That is what is the test we use for normalization. Now, I'll give one more item, and then I will take questions, and I'll give the control to Deepa, so she will show in a case study of end-to-end process. Now, when we want to do all this in a project or all these things in an industry, what we do is first we get something called as functional requirements from the business. Okay, this document will illustrate what they need in a database, why they need, how they need, what are the rules they want to enforce. That is what is defined in the functional requirement document. This document comes to the technical folks or the IT folks. They review this document and convert this into a technical specifications or technical code. they will write and they will do this one. That is called as the technical requirements document. And then they implement, then they test, and then they move it to the production. So in this functional requirement document, a very simple way of identifying what can constitute table, what can constitute relationship. I'll just give a simple language. Okay. Okay, I'm just creating my own logic here and my own illustration just for making it simplified. Okay, a requirement document is written. We need to create a database for storing student information, and the student can enroll into 0 or more courses, and a course can exist with or without a student. That's they write in the requirement document. Now, very easy way is all the nouns will become okay. So when you look into this specific requirements and all the names, if you can, that will become your entities. Very simple way of identifying. Now, students can enroll into 0 or more courses. That will become your relationships. Deepa will illustrate how to do it. Now, here we are telling it 0 or more courses. Then that will become the cardinality of the relationship between those two tables. That's how this will work. So this is a simplified way. So what we do is first we get the requirement document, then we create an ERD, then we DDL, then create structure, then DML for inserting data, then select statements to retrieve data. Okay, this is the normal process which we will go over. Any questions so far? I covered almost 12 hours of a DBST 651 lecture in an extract of 30 minutes. Just to give you very simplified, we really don't want to go into technicalities. I just converted into an easy English for everyone to understand what we are doing in the class, because we are not expecting you to be coders. We are expecting you to understand what goes into creating structures, when we do ETLs, when we do data extraction, and when we are loading tables. All these things, I'm covering the basic fundamentals. I'm not asking you to be the masters of SQL at all. Are you clear? So you can unmute your microphones if you have questions. Please ask me now. Deepa, was there any questions, Deepa? Christiana?
I haven't seen any come across yet.
Okay. Do you want to take control, Deepa, now?
Sure.
Hey, this is Majed. Can you hear me?
Yes, Majid. How are you?
Great. Thank you very much. It's a great introduction, and good evening, everybody. I want just to add, it's a great information, but in addition to that, I think you need to be sure as the first time using the workbench to be familiar with that GUI, because sometimes, what we have, we give you a script, so the script is there, like exactly what Professor Manta mentioned it. But you have to be familiar with the workbench, how to to load
Yeah,
that,
that
how
is
to
what
run
we
it.
are showing, Majid. We
Right.
will show
Perfect.
them.
Excellent.
Yeah, yeah.
Excellent.
That is what
Excellent.
that's the exact thing I wanted to cover. So first, I
Exactly.
want to give them the introduction, and I am giving
No,
over
this is
to
perfect.
Deepa.
This
Yeah.
is perfect. Yeah.
Yes.
Excellent. We're on
Thank
the
you.
same page. Yeah.
Yeah.
Back. Thank you very much.
Deepa, just explain your scenario, what you're doing in simple English, and take them how you create your ER diagram, and then how you create your statements, everything. Okay?
Okay. Hey, everybody. I hope you guys can hear me. So I'll start off with a simple example that came up at work this week. We had a requirement that said we need to start collecting student phone numbers in order to send text messages in case there is any emergency situations in the university. So just to take it to a very granular level, I know that model can go really complex really quickly, but at a very granular level, the requirements we got was that if we need to start collecting we need to have a table that stores student phone numbers. So, and we already have a table called student in our database, and what we're trying to do is add on another table called phone numbers, and then we need to create a relationship between student table and phone number table. So and then once we have all these requirements on hand, like we just spoke about, and then one more requirement was that we need to ensure that there is at least one or more phone numbers for every student. This is important because that is the only way to communicate with students in case of real emergencies. So that translates into a relationship, and I'm gonna talk about how that translates into a relationship. So at a very high level, we need a student table, because that's the noun I heard in all of the requirements. We need a student table. We need a phone number table, and the student needs to be connected or related with the phone number table by some sort of relationship that explains that every student should have at least one or more phone numbers, and every phone number should belong uniquely to one student. So if I have a phone number in the phone number table, I should be able to trace the student record using that phone number. So these were my requirements. So put it in based on what we just heard. So if we just put that in sequence, the nouns we heard were student and phone number. So student became a table, phone number became a table, and then every student has to have a phone number. So that has part has now become the relationship between the student table and the phone number table. So this is how we presented our design to the team this morning. So we said at a very high level, I'm going to start fresh. Let me back up a little bit and start showing you how to access ER diagram. So I'm inside the virtual lab here. You can click on the Start menu and search for a tool called ER Assistant. So this is ER Assistant, and then it has all Windows-based menu, and it's pretty self-explanatory. If you just hover over it, it's going to tell you what each icon stands for. Let's start with the new file. So now we started off with an idea that we need one table called student. So let's start by creating the table. And then we need another table called phone number. So now we have our two tables, student and phone numbers. They're kind of empty shells at this point. Now we need to add the attributes that describe each table. So for a student, typically a student, like what we just learned, we need to have a numeric ID to be identified as the primary key. So I'm going to start and describe one column as primary key, and I'm going to call it student ID, and then a student can have a first name, last name, and so on. But just for this purpose, I'm just going to stop at these three attributes. And then coming to phone numbers, again, phone number, we need to have at least one attribute that is a primary key. So I'm going to provide that, and then I'm going to add another called phone number itself. This field collects the actual phone numbers, and then phone type. So some students can list several phone types. So there can be a home phone number, a cell phone, a work phone. So we need to classify in case there's ever a requirement to say how many cell phone numbers did we collect this month. So we will use this column to figure out how many cell phone numbers of the type cellular were collected in a certain time period. And then in addition, I'm going to add a column called student ID. And as we talk more about creating the tables, I'll describe why we added student ID to this table. Now that we have all our columns, we can close it out, and now you see that we have two tables like we described before. But these two are kind of independent entities at this point. They're not related to each other. So we need to build a relationship. In order to build a relationship, you will click on this Relation tab and click New and specify a name. Usually, so there's the relationship names are usually verbs. They signify some action. So in this case, I'm choosing a simple verb like has. So it's saying every student has one or more phone numbers. So this is the trickiest part. You need to pay attention here. Here I'm picking the entities that need to be connected or that need to be bound in a relationship. So I picked student, I picked phone number. So on my end, I'm going to say a student can have one or more phone numbers, and and the phone number at any point a phone number should be traceable to just one student record. So let's close it out. So this is what it looks like. This is what a relationship looks like, but I haven't enforced any strict rules against this. So at this point, it's very loosey-goosey. I'm saying a student can have many phone numbers, and at any point a phone number can belong to one student. But if you want to tighten up this rule, let's say your UI has a very strict rule that says a student record cannot exist without at least one phone number. That's when you'll have to enforce some extra rules to protect this data. So now we're saying a student should have at least one mandatory phone number, and then a phone number should belong to at least one student. So now you'll notice a change in the diagram. You'll see how this second line appeared. So this is a binding thing. This is saying a student should have at any point should have at least one or more phone numbers, one or several phone numbers. So if you if you search for crow's foot notation, what I'm trying to say is that this representation is a form of crow's foot notation, which shows the relationship between two tables. And whenever the line is one and three triangle type things, it signifies like one to many, which means that a student can have at least one and several other phone numbers, one or more phone numbers. At the same time, the phone number at any point should be traceable to just one and only one student. So if I search by a phone number, only one student record should be returned by the application, and you can enforce that at the data level using this kind of relationship diagrams. So that is ER diagram at a very high level. This is how you draw, and you can, in case you want to ever write some notes about your ER diagram. You can start a new notes section here, and you can list all your assumptions that you're using in order to create this diagram. This is just a nice way of indicating what this diagram, why you built your tables this way, why your relationships are what they are. So it gives a quick picture of what you see on the page here as a diagram. And now, so this kind of becomes a blueprint for you to build your table. So this is the idea. So when people actually design their tables, they look at the ER diagram first, and what they see on the ER diagram actually translates into the DDLs that we were just talking about. So I'll stop at this point and see if you have any questions about the ER diagram.
I got a question about what we're looking at here for phone number. For the ID, what for that primary key, what were you intending to put into that ID? The actual phone number or some other identifier, numeric identifier?
It's going to be a system-generated identifier. The phone numbers are in the second column here, phone number.
Right, because I think, I'm looking at this, and it seems like in the end, with their referential integrity, this would be incorrect. I say that because it is possible then if you're using a system generated identifier and then the phone number that you could have two students that could use the same phone number. So that means this RI is not correct.
So let me, may I know who is speaking?
This is John Carr.
John, okay, you're truly valid. For instance, let me give a scenario and let me tell, let you tell if it is valid. Me and my brother, we are in a school and we give our home phone number. As the number. Would it meet the need? So both me and my brother will have the same phone number, correct?
That would be correct, because if you're saying that it's going to be a system-generated identifier, then that would mean you'd have two unique IDs, but they could have the same phone number for two different students. If you wanted, to me, if you wanted to go and have some uniqueness here, then you would go through and you take the phone number, make that a numeric, and then use the phone number as the actual primary key to phone number. Wouldn't that be correct?
You can do it. That's what you need to understand, the rules of your governing organization. If your organization or your university says the phone numbers have to be unique, then your example will cite. But you should look at the practicality of the table. In my example, what I have mentioned to you, if you make phone number as unique, either me or my brother will not be able to enter their phone number. So you need to understand when you're constructing, that's why I said in my example, you need to understand what are the rules governing the requirements. In the requirements, if they say the phone numbers has to be unique, you're perfect. Like for example, user ID table. When we log into a system, you can enforce the user ID to be unique. How can you create the user ID as an unique? You can have an email as a user ID because each person has their own email. So you need to look at the rules, then enforce them in how you create your tables, primary keys, foreign keys, cardinalities. Am I making sense, John?
Oh, no, yeah, you're making sense. It's just the way that I see it, that you're just breaking normality here.
Yes.
That's all.
Okay. Go on, Deepa.
Yeah,
I have a question as well.
Mm-hmm.
So I see that you have student ID under both of them. I assume that's because it's primary key on the left.
I can't quite hear you. Can you come close to the phone?
How about now?
Yeah.
Okay. So I see student ID is on is in both. Um,
I still cannot hear you.
okay. Can you hear me?
Yeah.
Okay. So when I had the same field in two tables, then when I hit the checkbox for to check for I don't know whatever it's supposed to check for, it singled that out as being incorrect.
Could you just, sorry, I did not understand the last part of what you said.
Okay. So I I guess in for assignment 2-1 or whatever the assignment is where we're using the software, I put a primary key in one and then the foreign key in the other. When I hit the checkbox to validate, I got an error saying that I shouldn't have it in both places.
Yeah, you can ignore that. This tool is not meant to draw full in, like, so you're saying you got a consistency error like this saying student ID is present in both tables.
Yep.
Okay, so you can safely ignore this one because this tool is just meant for student practice and it doesn't actually enforce any foreign keys. So if you were to use another commercial tool like a SQL Developer's Data Modeler, you wouldn't have this problem. This tool is not built to show foreign keys. In fact, so I shouldn't be actually entering in student ID here. It should know if the tables are connected, it should realize which one is the foreign key. But since this tool can't recognize that, I'm adding student ID in particular. Otherwise, there was no need for me to add that column.
Okay. So for the assignment's sake, do you put the foreign key in the second box?
You can do that. What you can do is you can edit this table, edit the attribute, and where it says student ID, you just type in FK, so we understand that this was meant to be a foreign key for this table.
Okay. Okay. I guess that works, and then it'll show up as something different, and I won't get the error.
Yeah, I mean it will still the consistency errors. It looks like it passed the consistency problem now.
Okay. Thank you.
No problem.
Right,
Okay, so
sorry.
go ahead.
Yes, in table number 2 for phone number, I'm curious, would it be violating anything if you use student ID as the primary key, since each student will have a unique student identification number?
You mean in the phone number table?
Yes, instead of the ID, which will be generated by the system, would it be possible to use, or would it work to use student ID as the primary key?
Okay. If that's the case, how will we accommodate the requirement that says a student can have one or more phone number types? So let's say I want to list my home number, my cell number, and my work number. Then I won't be able to insert because my student ID is 001. So now if we make student ID primary key, I gave my cell phone number. Now I'm not able to provide my home number.
Oh, okay. So in that case, it wouldn't work. I'm just being curious. Okay, thank you.
So again, and that brings me back to answering John's question. So John, sometimes we do compromise on normalization. We cannot enforce like a fourth normal form to meet all the requirements. Ultimately, business requirements kind of drive the way you build your databases. So sometimes it is like this case, we did compromise on one of the normalization rules. So this is not something unreal. This does happen in the industry.
Sure.
Diva, this is Majed.
Yes, sir.
Yeah, I want just to add exactly what you mentioned very well, that sometimes you have one student ID and you want to have their two phones, like, home or mobile. And if you try to do the student ID as your primary key in the phone table, DAS will not allow you to do that. And usually you have that ID is your primary key and the student ID is a foreign key. And as a rule, we cannot have two primary key in one table. So I think the setup is correct here. Thank you.
All right, thank you. So quickly, so a quick cheat sheet here. I didn't know if we would run short of time, so I typed up the script ahead of time. So once we have this blueprint or this ER diagram available, the next thing would be to start creating the data definition language, or the DDL that we've been talking. So as part of creating the DDL, I'm starting fresh and I'm trying to create a database. So I issued a create database statement to create a sample, to create one database called demo. I'm using the demo, and in here I'm creating my first table, student. So the commands I issue are create table student. This is the table name. Then student ID, and then I defined the data type, and I said not null means the student ID can never be null. Then first name, last name, and then I defined a primary key for this table has to be student ID. So that's one table. Next is the phone number table. So I created another table called phone number, or phone in this case, and I created ID as as a primary key, and then I have the phone number, and then I have the phone type, and then student ID, which is going to be the foreign key to this table. So once you define your primary key, the next thing is to define the relationship between student and phone number is defined by this foreign key constraint. So syntax, I don't think you should worry a lot about syntax. There are several online sites that help you with the syntax, or in fact have that PDF file handy with you when you start writing script. The only thing to understand here is that you're trying to create a foreign key constraint between two tables, and the general syntax is you're going to give the constraint a name, and you're going to say which column in this table is going to serve as the foreign key, and then there's another line that says references, which means which table should it reference while calling this relationship. So in our case we said foreign key STUPH on student ID column references student table and student ID in particular. And then there are some rules you can define. So it's saying on update cascade. So if I update anything, my corresponding table or my calling table has to be updated at the same time. And on delete restrict, in case I end up deleting and there's a child. So if I want to delete a student, but there is a record in the phone number table for that student, then your student table that row will not be deleted, because you'll come back and say there is a child row in this phone number table. You need to delete that before you delete the row in the parent table. So those are the quick rules. So I just did a little homework here, and I've created these two tables. Now I'm going to quickly insert some data into these two tables, which I guess you guys did last week. If there are any more questions, I'll take questions while I'm typing. It's kind of boring to see me type. Okay, so this is my first insert statement. Now that my first insert statement went through fine, it has one row is affected. If you want to insert more than one row into a table, easiest way is, now that you have a shell just copy this and then make minor changes and then run your statement. And for demonstration purposes, I'm going to insert something into phone table. So this is my primary key. This is my phone number. And it's going to be a cell phone. Then this belongs to student ID 1. Okay, let's test this out. Okay, that went through fine, so I'm going to insert another one. Okay, so what I effectively did just now is insert 2 phone numbers for one student, student ID 1. I don't have anything for student ID 2, and that's still fine, but we accommodated the request of saying, okay, for a student should be able to enter more than one cell phone number. Okay, I don't have anything more on my agenda unless you guys want. Is there anything else you would like?
Deepa, did you show them how to select the data?
Sure, I can do that. So in order to retrieve data, this is the simplest form. The simplest one, you say you want to get everything from student data. And
Select
then,
star.
And then this is if you want a particular student record. Should I go over table joins?
Yes, Deepa. I was about to say that. Just give them a simplified version.
Okay. So let me populate some more columns here. Okay. So I'm just trying to insert some more data into my tables. So now that we have our data populated, now that we built our data model, in the real world, occasionally, or more so, it happens that the data that you want, that something an application needs, may not exist in one table or that one table that you're trying to read from. And sometimes you need a few columns from table 1 and a few columns from table 2, and you need to join them in order to show that, in order to make it look like it's all coming from one table. And that could be done using a SQL operation called table joins. So table joins effectively works on the fact that there is a common column between table 1 and table 2 that you're able to join on, and you're able to bring back matching data based on some match criteria. So in my example, let's say I want to see all phone numbers that belong to student ID 1. So let's say I have a requirement that says show me the first name, the last name of the student, and all his phone number types. I don't want the phone numbers, but just the type of phone numbers he has supplied to me. So that data now exists in two different, first name, last name is in student table, and the phone types are in phone table. So we need to join these two tables and then present our data. And in order to do that, we need to do a table join. So in order to do a table join, it's like you start off with a select statement, and then you say, okay, so from what columns do I need? So I need first name, I need last name, and then from another table, I need phone type. So now you'll define what A and B means in this SQL statement. So we said, okay, those are the columns I need, and then we said from which table are we picking? So student table, and so what I did here is I'm calling student table by a short name called A, and then join phone, and I'm calling the phone by a short name B. Oops. On a common column that exists between both tables, which would be student ID. And then we have a limitation that we want to see only student 001's phone number types. Okay, let's see if this works. Okay. Oh, I did not say which table to pick from. Okay. So our student Joe has provided us 3 phone numbers, a home phone, a cell phone, and a work phone. So let me just show you the SQL statement one more time. So in here, like I said, I want first in the select statement, I'll list the columns I need to show in this final SQL, in this result. So I needed the first name, the last name, and the phone type. But I know that the first name, last name is from student table, and the phone type is from phone table. So what I did here is I called these two instead of saying student dot first name, student dot last name, I've used a short name. So I said in the context of this SQL query, if I use a dot, it means bring everything from student. if I use B dot, bring everything from phone table. So I'm saying I need first name from student table, last name from student table, and phone type from phone table. And then I'm saying there is a common column called student ID in both these tables. So join phone and student table on this common column called student ID, and then bring me back only matching values where student ID is 001. So this is a simple demonstration of a table join.
A simple rule is if you have two tables, one join should be present. If there are three tables, minimum two joins should be present. That's the rule of thumb. And more joins will help for data retrieval, but you have to be careful as well. Okay?
So by default, is a join considered an inner join?
Yeah, in this case, yeah, it's if I don't say, unless I say outer join specifically, it's supposed to be an inner join.
So any other questions, any other clarity anyone wants to ask? Please let us know.
Hello, can you hear me?
Yes.
I have a question. Is there any way we can have an another example of doing an update?
Sure.
Thank you.
Is this related to the safe mode error that you're saying?
Yes, it is.
Okay. I don't know that we can trace that. One more thing I wanted to mention is that I think maybe you guys noticed during the course of this demo, I got logged out more than one time. And if you guys notice this issue, please bring this to our attention. We need to work with the vendor. We've been reporting outage, like brief disconnect issues. But if you guys notice it, I can open tickets for it. And if you do notice any outages, please bring it to our attention. Okay. So this is an update. This is a very crude update statement I wrote where I'm saying update the student table, set the first name to Jim where first name is Joe. Okay, so let's see. Maybe this will trigger the error that you were talking about. Okay, do you see this?
Yes, that's the same error I get.
Okay. So it's so to disable safe mode preference editor. Okay, let's see what happens if you use a primary key.
Deepa, we need to go to the queries and change that save mode.
Oh.
So go to the query. You can read it there. Yep. Option preference. Go to the preference.
Okay.
And the preference probably under edit, probably, or yes, under edit. Preferences. Let me go to one of those on the left until you see the save mode. And the next one.
References, SQL editor. Okay. Save snapshot.
Yeah, the last one, the last checkbox.
Oh.
There you go.
Okay.
Then sometimes you have
I
to
was
reconnect.
Okay. But I was thinking, what if we use the primary key?
Sure,
Probably
That's
won't.
another, yeah, but that's the message to you that you have to turn on the save mode on. It's by default they kept it until you say, hey, I need to update.
Oh, okay. So there's more than one way to get past the problem. So in case your table does not have a primary key, which I doubt will ever be the case, then you'll have to turn off the safe mode, or you can always use a primary key in your update statement.
Equal.
Oh, sorry.
But to do things like this, updates, deletes, what I'm trying to say, best practice is to go through and include a primary key.
Mhm. And that's always the safest way to do it.
Yes.
So that was
Because
I was telling in the normalization concepts.
What if you had more than one Joe with a different student ID? Then you would be updating all Joes if you didn't use the student ID. Does that answer your question? Was it Joanna?
It does.
Okay.
It does. Thank you.
So either you have the option of turning off the safe mode or using the primary key in your SQL statement.
That's correct.
So we have covered the fundamentals of SQL. I just gave an overview. Then Deepa went over a scenario of creating an ER diagram and executing the structure, showing you DDL and DML. Anything else you need to understand? Any other questions? So we have recorded it, and we'll post the recorded link. Please review it, and if you have questions, please reach out. And as I told you previously, please start your assignments on Monday. Don't wait until Sunday morning and then rush for help, which is very, very difficult because everyone have families. We need to make sure of time and other commitments. So please seek help at the earliest. Don't get the help request at the last minute. It will be very tough and very difficult. Okay? So if there are no other questions, I truly thank everyone for taking their time and joining the webcast. And please stay connected, and either me or Majid will offer the next sessions based upon the observations and the difficulty of the concept. One of us will chime in and offer similar webcasts on Wednesdays. That would be the ideal. If we find suitable other days, we will inform you well in advance as well. Okay? Thanks, everyone. Thank you.
Thank you very much.
Thank you.
Bye-bye.
Deepa. Deepa?